Hi guys, if you've clicked the play button on this video, you should hopefully be able to hear my voice. This is the first lesson of our new topic, and I've decided that it'd be a good idea for us to crack on with the final bit of content I don't think you guys have done, so when we are back in the classroom, we can kind of focus on getting his assessment sorted and under our belt. So we're starting a new topic. It's called the challenges of resource management, and this lesson is going to be a bit of an introduction. We're going to look at what those resources are, and we're going to start to look at what some of the challenges might be. This is one of my favourite topics, and hopefully you find it equally as interesting. So all you have to do is, you have to listen to my voice and listen to this video by clicking the play button, which you've already have done. You listen to it and you complete any activities. Once you've done with listening to me and this PowerPoint, there's some questions on the final slide. I want to read them through and attach them to show my homework. It is a Word document, you can write them, I don't really mind, so I can have a little look through and see how we're getting on, if there's anything we need to improve on. So, to start off then, just a little quiz. So, feel free to just kind of play along. You can pause the video if you want to, but I'll do some natural pauses as well. So the first question is, how many litres of water does it take to make one apple? Is it A, 70 litres, B, 50 litres, or C, 110 litres? And the answer is 70 litres of water. To put that into some sort of context for you, a normal sized bottle of Coca-Cola or Fanta is about 500 millilitres. So it would take 140 of them worth of water to make one apple. Second one, what percentage of the world's energy came from fossil fuels in 2011? Fossil fuel being coal, oil and gas. Was it A, 63%, B, 84%, or C, 78%? It was C, 78%. So the vast majority of our energy still comes from fossil fuels, even though for some time now we've known it's had a huge impact on the environment, and we've also been told for many years that they are running out. Alas, 78% 9 years ago was from fossil fuels. I think that number would be a little bit lower now, and we'll have a look at that later in the topic. What percentage of the UK's water use is domestic? And that means how much of our water is used for people in their homes, so in the shower, in the sink, and the toilet, etc. Is it A, 22%, B, 55%, or C, 76%? The answer to that one is only 22%. So most of us think of our water, we think of it like say using the showers or doing our cooking, but our water use, only about a fifth of it is actually from what we do in our households. And that suggests that the rest is used in other areas such as industry, such as agriculture, farming as well. The last one, on average this is, how many extra calories does a man need per day compared to a woman? Is it A, 1,000, B, 500, or C, 200? The answer to that one is B, it's 500 calories more. So, like I said at the start of the video, we're going to be looking at some of the resources that are posing us challenges. There are three main ones. They are water, they are food, and they are energy. I'm going to go through a very brief description of all three today. And then our forthcoming lesson, we're going to go into a lot of detail, in particular into water. That's going to be our kind of topic of focus for the second half of this unit. So, what's to do with water then? Most of us think of water, we think of it needed for drinking, don't we? If we're thinking of drinking and maybe washing as well. But actually, water is really important in disposing of waste, in growing and processing food, and also in industrial manufacturing. So when you hear of things being made in China, when they're making your iPhone, or they're making your PS5, a huge amount of water goes into that process, whether it be from transporting the goods, whether it be from cooling the machinery that is making that things as well. So water, super important. The average person in the UK uses 150 litres of water daily at home, of which only about 4% is for drinking. So think how much water that is that we're wasting. So you have a big bath, or you're in the shower for 20 minutes, you're wasting a lot of water. And the problem with that is that over time in the future, our water is going to become more scarce. And we're going to get into that again later in the unit. But scarcity means there's not enough of it. If I'm in a sweet shop and I can't find any Kit Kats, there's a scarcity of Kit Kats in that shop. So, more than 1/5 of the world's population, that's over 1.2 billion people, live in areas of water scarcity, which means there is not enough water to meet all the demands. So that means that 1.2 billion people, that's a huge number, are struggling to access water. I think we, as a country, as a generation, find it very difficult to imagine that, because most of us have had it where we can turn on a tap, we can go down to a shop and get water. There's never been many issues. You might have it sometimes when your water doesn't go hot. You might have it where sometimes your pipes break, but for the most part, we have pretty good access to water. If you're one of those 1.2 billion people, it might be that getting water, if you're cooking that day, might be difficult. It might be that there's not enough water to have the safe amount of water in a day to drink. And that's the problem that they're facing. It's geography, and that basically means that there's going to be some sort of divide when we map this on a world map. So there's a map on the screen here, which you'd hopefully be able to see. And as usual, we can see quite a clear pattern. Well, I think I can see quite a clear pattern on here. Oh, sorry, hang on. Let's go back. So I think I can see this little pink line here is showing that it's the Brandt line. We've looked at this before in terms of development. Now, the blue on the map is where there is basically no water scarcity. The orange is where there's physical water scarcity, and that means that there are physical geography reasons, like the climate, that mean there's no water. The little pinky colour is the approach and then getting towards water scarcity. And the purple one is economic water scarcity, and that means that they can't afford it. There's not enough money to go around to pay for it. Water is really, really expensive, and in this country, you do pay every month for your water. It's not a huge amount, but there was a story in Venezuela, in South America, and the idea or the problem there was that they worked out that people were paying about 60% of their monthly wage just on water. So that's really hard for us to imagine, but 60% of what they were earning was just going towards, never mind food or never mind schooling or transport or anything of enjoyment on top of that. And that had really, really, really big consequences for that country. So again, if you're looking at the pattern, it's quite clear we have one of those north-south divides, where in the north, mostly it's okay. In the south, it's not looking too hot. Particularly the physical water scarcity, you will notice even in the USA over here in Mexico, it's along the equator, the hottest places in the world. And the problem is that as we get warmer with climate change, there are going to be more areas in physical water scarcity. And that's a kind of harsh reality we're going to have to cope with. In terms of water use, if we're looking at kind of making it linked with development, for a HIC, most of our water is used in agriculture and it's used in industrial use as well. Whereas if we went to an LIC, it would mainly be agricultural use. That's a bit of a weird graph to understand, but the way I think about it is we know that in the LICs, the proportion of people working in that primary industry, the agriculture, the farming, the fishing, etc., the proportion is much, much higher, and therefore they will require more water use as well. As you move into the secondary, the tertiary, the quaternary industry, you have more industry, and therefore your industry might need more water. So that's why there's kind of the different percentages on the two different pie charts. So, if you want to pause the video here, I've got two more little maps on the screen. The first one is 1995, the second one is 2025. So pause the video and there's a few notes. How will water stress change between 1995 and 2025? Okay, so on the map I can see that as we go into the future, there are going to be more places with that water scarcity or water withdrawal. It's going to happen a lot more in Africa and the Middle East, and also it's going to be a lot worse in the USA over here, and also parts of Western Europe as well. Okay, so the second resource is energy. So when we talk about energy, we're referring to quite a lot of different things. Mainly, we're referring to electricity and fuel, so things like petrol, diesel, etc. So energy is an absolute requirement for economic development. If we didn't have power, if we didn't have electricity, we didn't have fuel, we would not have development. A lot of the jobs wouldn't exist. Modern society would not exist in the way that we know it. And in the past, it was always the case that most countries could kind of depend on their own energy resources. So the UK back in, or from about the 70s, earlier than that, had a huge amount of coal, and most of Britain's energy use was powered by that coal. As it ran out and became obsolete, we now rely on other countries for our energy, and that's where it becomes quite complex. Again, energy consumption is starting to increase, and there are going to be problems that are associated with that. Got another graph here, one of the maps, sorry, and this shows the average or the annual consumption of energy. So the little purpley colour is more than 400 British thermal units, whereas the light blue is less than 5. So let's take the USA, for example, over here. The USA has between 250 and 400 million British thermal units consumed per person. Whereas if we go over to sort of sub-Saharan Africa over here, it's less than 5. That's a huge amount of difference. And it all comes down to development, because if an American's coming home from work, they might turn on Netflix, they might turn on their kettle, they might have one of those fancy Ring doorbells that shows you the video, they might have an Alexa in multiple different rooms, all of which requires consumption of energy. They might have a big car which they use to travel to work and back, which burns diesel. Whereas, if you're in one of the less developed countries when you go home, you would have much less access to technology. You would maybe not need a car, you'd maybe walk places or go on a bicycle instead. So that's why there's that difference there. And the last resource is food. So, food is one of those ones that no one really ever thinks about when it comes to resources. We always think about water and energy for some reason, but I think food is probably one of the more important ones. And that's because food is a resource. It doesn't just happen naturally. Well, some food does, obviously, but on our scale of sort of the world population, we have had to develop huge agricultural systems which enable us to feed everybody, and that's going to change, if I'm being honest with you. So having a high calorie diet, having enough food, including meat and dairy, it's a really, really, really important thing. But unfortunately, across the world, up to 2 billion people suffer from undernutrition or malnutrition, and that can result in a large range of disease and illness. So essentially, if food, the resource food disappears or goes down, we're going to have more people that are at risk from disease and illness. The WHO suggests that we need about 2,000, 2,400 calories per day to be healthy. People are not having that amount of food, and that's because of food production factors. So if we go to the next graph in a minute, in some climates it's very, very difficult to make food. In other climates, it's becoming more difficult for people to afford the right level of nutrition that they need. And as climate change takes hold in the future, again, this is going to get worse. So this graph here shows the levels of malnourishment. So the green is where it's very, very low. The brown is where it's very, very high, and you can work out everything else in the middle there. Again, it's one of those graphs where the trend, once again, is very much a north-south divide. Most of Western Europe and North America has very low amounts of malnutrition. The only surprising one on this graph is sort of China as well, and Mongolia over this side here. And the reason that's surprising is it doesn't fit the other patterns, but there's still quite a lot of, well, there's a moderate amount of malnutrition in those countries, despite the fact that they are NEEs, they are still developing. But once again, there's a clear divide. The issue is going to be in the future is, well, okay, is that going to get worse? And if it does get worse, whose job or whose responsibility is it to fix that? We're going to be looking at that as a separate lesson. Okay, so that's the content done for our little introduction. We've got 3 questions now I'd like to answer. I'd like to upload these to show my homework. The first one says, what are the 3 main resources which humans rely upon? Hopefully we should get that one. The second one, what are the consequences of food, energy and water shortages? So for that one, what I mean by consequence is, well, if there are food shortages, what is the consequence of that? What problems is that going to cause? What will happen to people in that scenario? Use the resources from the slide, but also if you can think about the wider consequences for society, for economic development as well. And the last question, this is kind of an opinion one. It just says, which resource do you think will pose the greatest challenge in the next 20 years and why? So just choose one of the three and decide why you think that one will be the most challenging in the future. So if you chose energy, for example, okay, well, why do you think energy might be more challenging than one of the other ones in the future? Upload those to show my homework, and then I will hopefully be able to give you some feedback on that quite promptly.